TEKS 9B and 9D, exponential graphs and their attributes. Okay, so we are starting Unit 8, and Unit 8 is all about exponential functions. So before we look at the examples, I want to look at the note section. So the attributes that we're going to be finding on an exponential function is going to be the y-intercept, the asymptote, and then whether or not it's a growth or a decay. So the standard form for Algebra 1 of an exponential function is y equals a b to the x power. So the a value is going to be our y-intercept. So whatever number comes first is our y-intercept. And just like on any other graph, our y-intercept is where it crosses the y-axis. And it's also called the starting value. So you'll notice that in a lot of these examples we use applications, so real world problems, and instead of calling it the y-intercept, they may call it the starting value. So that's A. Okay. Now I'm going to skip asymptote real quick, and I'm going to go to growth and decay. So that B right here is going to determine if it's a growth or a decay. So this goes over here with growth and decay. So we know it's a growth if B is greater than 0. And we know it's a decay if B is less than 0. So what I mean by growth and decay, if I was to draw two graphs, so right here, one looking like this, and then one looking like this. If we look at it from left to right, this first graph here is going down. So this is a decay. So if we go from left to right, we know that this graph is going down, so it has to be a decay. And then again, if we look at this graph from left to right, we notice that this graph is going up, so it has to be a growth. Okay. And then the last thing we're going to learn about for the attributes is the asymptote. So an asymptote, I'm going to write a definition for you, is a line on a graph where the curve, or in our case, the exponential function, so it's the line on a graph where the curve approaches, I think I spelled that wrong, approaches the line infinitely, but will never cross it. So for example, if I have the graph that looks like this with my exponential function, we'll notice that the asymptote is right here at y equals 0, or in other words, the x-axis. Notice that right here, let me get a different pen, my graph slowly approaches that red line, that y equals 0, but it will never touch it. So it will go on and on forever, slowly getting close to it, but will never touch it or cross it. So that's what an asymptote is. So in Algebra 1, an asymptote in this case will always be y equals 0. We are not going to learn about asymptotes that are greater than that or less than that. Our graphs in Algebra 1 will never cross over the x-axis. Okay, so let's look at example 1. Example 1 is looking at this graph here. And in this graph, it first wants to ask us if it is a growth or a decay. So remember, we read it from left to right, and we look at the line. is that line going down or is it going up? It's going down, so it must be a decay. And then it says, what is the y-intercept? So the starting value. So remember, the y-intercept is where it crosses the y-axis. So right here is where it crosses the y-axis. And that is going to be about, let's say, 32. But if we look at the y-axis, it says the value of cars in thousands. So this is actually 32,000. So remember, this is a real world problem. 32,000. Okay, then it says, what is the asymptote? Remember, I said the asymptote is always, in this case, going to be y equals 0. So no matter what your problem is, remember the asymptote is always y equals 0. In our graph, in our example, it doesn't show the entire graph because it cuts off at 10 years. But if it was to go on forever and have an infinite amount of years, it would never cross over that x-axis where y is equal to 0. Okay, the next question says, after 4 years, how much is the value of the car? So we're going to find 4 on years. Remember, years are down here, so here's 4. And then we have to find where this 4 touches the line on the graph. So it touches it about right here, which is about, let's say, 17,000. So after 4 years, the car, which originally was 32,000, is now only valued at 17,000. Okay, let's look at the last question. It says, after how many years will the car value decrease to 8K? So now we're going to do the opposite. We're going to find on the graph where it is 8K. So it's about 8K. So I would say 8 is right here. So that's about right here on the graph. And if we look down, we know it will be worth $8,000 after 8 years. So 8 years. And that was example 1. Okay, example 2. Remember, our first question says, is it a growth or decay? So what we need to do first is we need to read it from left to right, and we need to see, is this line going up or is it going down? So since it's going up, we know it's a growth. Next it says, what is the y-intercept? Or in other words, the starting value. Remember, the y-intercept is where it crosses the y-axis. And if we look right here, it looks like it crosses the y-axis at this point. So since this is 10 right here, let's check if it's going by 2s. 2, 4, 6. Yeah, it's about, there's a line missing right there. So 2, 4, 6, 8, 10. So if that is a 2 right here, this line is a 2, that means our point, our y-intercept must be 1. But 1 what? It says number of bacteria. So 1 bacteria. Now it says, what is the asymptote? Remember, in Algebra 1, the asymptote is always going to be y equals 0. Because if we look at that orange line, it never crosses the x-axis. It gets really close to the x-axis right here, but it never crosses over it. Okay, let's look at the next question. It says, after 15 hours, how much bacteria is produced? So we need to find 15 hours right here on our graph, and we need to match it up with that orange line to see how much bacteria has grown. So if we draw it all the way up here, looks like it connects to that dot there, and that dot looks like it is, remember, we're just estimating here. So it looks about 32. So it increased to 32 bacteria. 32 bacteria after 15 hours. Now the last question says, how many hours will it take for the bacteria to reach 2? So the bacteria to reach 2. So if we look right here, I'm gonna erase some of the stuffs right here. Okay. So if we look right here, 2 is here. And if I draw this across, it looks like it crosses here. So in order for us to reach 2 bacteria, it would take 3 hours. So remember, at the beginning of time, at 0 hours, we were at 1 bacteria. And then at 3 hours, we moved to 2 bacteria. And after 15 hours, we moved to 32 bacteria. Okay, this is your notes. Remember, if you have any questions, please email me at my school email.